Okay, now let's work through some examples. So I'm going to take you to the slides. Let's start with this sentence, A arrow B or B arrow A. So we have another connective now. So far you've learned the rules for or and. Now I'm going to show you the rule for arrow. So let's start with that. Over here in our table of rules, I've added a column for A arrow B. Here's what it looks like. Why does it look like this? We can argue about that later. When A and B are both true, A arrow B is true. When A is true and B is false, A arrow B is false. And in other circumstances, it's true. Why? Don't worry about it. We could have an argument. For right now, just try to remember it. I guess if I want to give you a very short answer, put it this way. Because we're doing truth functional logic, any connective has to have a table like this. It has to have a rule associated with it. If it's a binary connective, you're going to have to give answers to those four options, the four different ways that A or B could be. A true, B true, true false, false true, false false. Any other option would be worse. Any option other than having the rows go true, false, true, true. Any option other than those, that specific one would be worse. If you're interested, I can point you to, there's a really nice video by Branden, who's kind of a fantastic philosopher, arguing for this at slightly more length. A lot of fun. I can send you there if you want. For now, you might just want to brutally memorize this. That sounds wrong. Just memorize it. The important thing to notice, I said before, this is our one connective that is asymmetrical. So notice that here's the way that works. When just one of A and B is true, the order of the true and false makes a difference. So for or, both of these middle rows are true. For and, same again. Both of the middle rows are false. They're the same. A and B, B and A, it's going to come out the same. But A arrow B is different. When A is true and B is false, A arrow B is false. But when A is false and B is true, then A arrow B is true. It's confusing. You'll have to get used to it. Sorry. Okay, so here's the sentence that we are starting with. Here's our example sentence. A arrow B or B arrow A. Let me clear out what we had last time. Notice, since in this case we have only two atomic sentence letters, A and B, I don't need, oh, actually I'm deleting the wrong thing here. I only need 4 rows. I don't need the full 8. Okay, so I'm going to delete the old A column and the bottom 4 rows. And now we're good. Notice, by doing that, we're back to the pattern that we had before. The rightmost atomic sentence letter alternates true, false for the 2 to the power of 2, which is 4 times we need. And the next one over goes 2 trues, 2 falses. Okay, so let me clear out this. Clear this out, clear that out, clear this out. Okay, so here's what we're going to do. First thing we want to do when you are doing a truth table is identify your main logical operator. So the thing that would be at the very top of your tree. In this case, I'll leave it to you to check this for yourself. In this case, it's the or. That means anything else, any other connective, I'm going to have a rough work column under that. And then my main answer is going to be the thing under the logical operator, the main logical operator, excuse me. So I'm going to have a column of capital letters under the or. I'm going to have a row of lowercase letters under the arrows, each of those arrows. And those are the things I'm going to put together at the end. So let's do our first rough work column. So focusing just on this, on A arrow B. Row 1, we're assuming A is true and B is true. And we're in the arrow column, A true, B true. That means I have true. What about when A is true and B is false? Well, then A arrow B is false. What about when A is false and B is true? That's true. Oh, these are capital, aren't they? Oops. Come on now. True, false, true. And when A is false and B is false, then A arrow B is true. Why? Because I said so. Okay. Next, I'm going to do my rough work for this second arrow sub-sentence, B arrow A. Now remember, we're looking at the same rule for A arrow B, but remember the order of the atomic sentences matters. So in this case, again, I'm going to put my fingers on the two columns, and I need to keep track of which one is the antecedent finger and which is the consequent finger, so I know what I'm looking at in that arrow rule table. So here I'm looking at B arrow A. So B is my antecedent and A is my consequent. In this case, they're both true, so I'm definitely on line 1. So that means B arrow A is true. Okay, now they're different, so the order matters. B arrow A, and in this column, B is false, A is true. So I'm looking at false arrow true. So when I look at the table, that's this row. That sounds confusing, doesn't it? Because over here I'm giving these rules in terms of A and B, and over here I'm using A and B, but this time I have to put B in the A and A in the B. Here's how you should think about it. Even though I haven't drawn it this way because my computer isn't all that fancy, when you're looking at a table that's giving you the rules, that's telling you how OR works in general, how AND works in general, how arrow works in general, think of the atomic sentences here as being in scripty font. And remember, the scripty font letters work different from the italic ones, right? These are standing in for any sentence at all. It doesn't even have to be atomic, and it definitely doesn't have to be the letter A. Whereas where you're checking a specific formula, a specific sentence of TFL, then these are going to be real sentences. Okay, sure enough, if you look in your textbook, there is an appendix in the back, a handy little appendix in the back that puts all of the truth table rules on one page. And when you look there, the things in the atomic sentence column over on the left are in fact scripty. They are supposed to stand in for any sentence at all, complex or otherwise. Okay, so what's happening here when I decide what to put in this row under B arrow A, I am putting the actual atomic sentence letter B, like a regular capital B, into the scripty A space in this truth table stating the rules, right? So B goes in the antecedent spot in the conditional I'm looking at. A goes in the consequent. So down here, I'm doing B arrow A, and I'm on the row where B is false, A is true. So I'm looking at false arrow true. False arrow true, that's this. So this sentence is true on that line. Whereas on the next line, I have B arrow A is true arrow false. True arrow false is false. False. And then false arrow false is true. So I've done my rough work for this bracketed subsentence and my rough work for this bracketed subsentence. Now I'm going to take those two columns, this one and this one, I'm going to put them together with an OR rule. So now I am done with the arrow rule. I'm looking at the OR rule. OR rule says the only way you get false is if both sides are false. So let's go through here. Row 1, I have true or true. That's true. I'm switching over to capital letters now because I want to indicate this is the main logical operator. This column that I'm typing in now is my official answer. If you're writing these things by hand and uploading a photo or a scan, you can do this any way you like, but you have to pick something. You could use a different color for your official answer. You could cross out the things that are just your rough work. You could underline, you could point an arrow at it, whatever you want to do, but you have to do something. If there are multiple columns of letters under a sentence, you have to tell me which one you are counting as your official answer. And I'm going to ignore the rest. Okay, so next we have false or true. That is true. Then we have true or false. The true from here, the false from here. That's true. And then we have true or true. That is also true. So, hey, look at this. Our original sentence, A arrow B or B arrow A, that is true on every line of its truth table. Now, what are those rows of the truth table representing? They're supposed to represent different possible ways the world could be. And in fact, those are all the ways the world could be. A can only be true or false, B can only be true or false. And that means there are exactly 4 ways the world could be, either A true and B true, A true and B false, A false and B true, or both of them false. And we have found in every single one of those ways that the world could be, our original sentence was true. That means our sentence is necessarily true because it's impossible for it to be false. How do we know? Because we checked every possibility, and in every possibility, the sentence was true. Another word for a necessarily true sentence, when it's necessarily true because of its truth table, we call it a tautology. Tautology is a technical word in your formal logic. It's also a real word in the real world, referring to like sentences. So when people say things like, it is what it is, that's a tautology. It's not necessarily the same kind of thing. In our class, tautology means necessarily true because of the truth table. We also have an adverb, tautologically. When we say something is tautologically X, we mean that it's X in virtue of its truth table. So something tautologically true in this sentence, you could say that. It means it's true in virtue of its truth table. If something is tautologically valid, what kind of a something? It's got to be an argument. Remember, arguments are the things that can be valid. If an argument is tautologically valid, that means it's valid and the truth table shows it. If a set of sentences is tautologically consistent, that means it's consistent and the truth table shows it. Or maybe as far as the truth table can tell, it's consistent. Is that the same thing? I don't know. We can talk about it. Okay, that's that. Let's do another example. Suppose we have this, A and B, arrow B or A. I'm going to copy paste that. A and B, arrow B or A. So again, we're going to have two columns of rough work and one column giving our main answer. Again, we have 4 rows because we just have A and B. We just have the 2 atomic sentences, so 2 to the power of 2 is 4. Okay, but we're doing the rules in different orders. So A and B, remember, and that's the one that is true only when both parts, both conjuncts are true. So our rough work column for A and B, that's going to be true on this line where A and B are both true. It's going to be false on all the rest because in each of those lines, at least one of the 2 is false, so no luck. Okay, second rough work column, B or A. Remember, or is the rule that is true everywhere except when both sides are false. So row 1, true or true, that's true. Row 2, false or true, that's true. True or false, that's true. False or false, that's false. You'll notice when I read this off, I said false or true, even though this line says true, false. That's because we're going B or A, not A or B. I know I told you with everything except the arrow, all the binary connectives except the arrow are symmetrical, but I still think it's just good hygiene to try and pay attention to the order because sometimes it matters, and if you get sloppy about it, then you'll be burned. Gross. Okay. So now I've done my 2 rough work columns. I've figured out this. I've figured out this. Now I'm ready to stick those things together with an arrow rule for the arrow. So I am getting true arrow true. I check that column of the arrow rule. True arrow true is true. False arrow true. False arrow true is true. Remember, false arrow true is true. It's just the true arrow false row that is false. Okay, false arrow true again, still true. False arrow false, it's also true. Hey, we have another tautology, another necessary truth. Okay, you probably want more examples, but sun's going down and I'm tired. So I'll record more of these soon. If you have questions, tell me about it. Thanks, guys. I'll talk to you soon.